Hi everyone, so let's get back to the fractions conversations that we were having. Slightly different format, but here we are, section 2.3. So we are on page 32 of your activities book. Now, if you remember, we were talking about our new definition of fraction. So for example, 1/3 is something you need 3 of to fill the whole. And when we look at something that's called 2/3, we can write it as 2 1/3. So this, if you remember, is the size of the pieces, and this is the number of pieces. So the size of the pieces is how many of them you need to fill the whole, and the number of pieces, how many you actually have. So if we look at the strip diagram, this is our whole. We have thirds. So if we wanted to fill the whole, we would need 3 of them. All right, and check that that makes sense. And if you, and what you have is shaded green is 2 of them. So there's 2 pieces, and you need 3 of them to fill the whole. Now on the number line, we have our whole is between 0 and 1. On the number line, the whole is always the distance between 0 and 1. Okay, so this is our whole, is the distance between 0 and 1. So the distance along the line. If our 1/3 is this much, then we need 3 of them to fill the whole, which makes sense. And our number at 2/3 uses 2 of them. So then what happens when we look at this expression and we say, all right, let's quote multiply top and bottom by the same number. Now that's a trick, that's a leap of faith. So when you say that when you multiply the top and bottom by the same number, you get the same value. But we really do need the children to be able to explain that and make sense of that. So what happens if we take 2/3 and we multiply the bottom by 4? So we are saying that you need 4 times as many pieces to fill the whole. Okay, so you need 4 times as many pieces to fill the whole. So are the pieces bigger or smaller? So you're making the pieces, makes pieces 4 times smaller, right? Or you're cutting each piece into 4 different smaller pieces. Now, when we're multiplying the 2 by 4, we're saying that we have 4 times as many pieces of those smaller pieces. So does it make sense that if you make the pieces 4 times smaller, that you will need 4 times as many of them? So think about that. On the picture, instead of using the thirds, we now cut the thirds into 4 pieces. So we have 4 times as many of them as we need to fill the whole. So instead of thirds, we now have 12ths. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We need 12 of them to fill the whole. Now, how many of them do we need to fill our green space, right? Which used to be 2/3, but now we have 1, 2, 3, 4, 5, 6, 7, 8 of them to fill the green space. So we also need 4 times as many of them to fill the green space. In fact, if we make the pieces 4 times smaller, we need 4 times as many of them to fill anything, to fill the whole, to fill the green space, to fill anything. Once you make the pieces 4 times smaller here, you need 4 times as many of them to fill any distance or any amount that you need. So when I'm going to ask you to work on this, if you need to pause this video, please do. Now, when you draw it, let's look at how this is going to appear. So 1, 2, 3, 4, you need 5 of them to fill the whole, so that's our whole, right? And what we were looking at is 4 of those fifths. Okay, so this is our whole, and the shaded area is our 4/5. So why is it that when we multiply the numerator and denominator by 3, we get the same value, the same shaded region? Remember, multiplying the denominator by 3 makes pieces 3 times smaller, because you need 3 times as many to fill the hole. So if you make the piece 3 times smaller, now it's going to be this piece. So that's our 1/15. Now, you need 15 of them to fill the hole. Now, how many of them will you need to fill the shaded space? Well, you had 4 large pieces. If the pieces are now 3 times smaller, then you will need 12 pieces to fill the hole. Let's check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right. So I would like you guys to think about what parts the students might find confusing in the math drawing. Now, more importantly, what happens if the student is using the old definition of fraction? Now remember that every Monday and Friday and Tuesday evenings I'm going to have office hours or drop-in hours where you're welcome to come and talk to me about any of these questions if any of this doesn't make sense. Now you will see on the schedule that some of those are just anybody coming in, we're all having a conversation together, and then some of those are going to be more by appointment. All right, so this is section 2I. So that's our, quote, equivalent fractions, or the idea of multiplying the top and bottom by the same number. Now, generally in class, I actually prefer that students don't say multiply top and bottom by the same number, or things like do the same thing to both sides, because that gets confusing. Those statements are much too broad to actually be helpful. All right, let's take a look. We're going to look through 2J. We're going to skip that. But here is our next activity about common denominators. So here we are. Now that we have looked at equivalent fractions, we can also see what kinds, how we can make sense of common denominators. Common denominator is something that we throw around all the time, but students really don't understand what that means. So for example, let's take a look at our first setup. We're asked to compare 3/4 and 5/6. Now, notice that in quarters, right? So when we have 3/4, these are size of pieces, right? So the quarter is the size of the piece. We need 4 of them to fill the hole. And this is how many number of pieces we have. So we have 3 of those. Now for the 5/6, we need 6 pieces to fill the hole. And this is how many we have. So we're comparing some number of fourths with some number of sixths. And that's going to be difficult because they're not the same size at all, so we need to somehow be able to cut those pieces into smaller pieces that we can actually compare. So let's take any number. If I can figure out what a fourth of a number is and what a sixth of a number is, it would be really helpful, right, to figure out how we could make both of those fractions, both of the unit fractions, into a similar form. So, for example, do we know a number that we can find a fourth of and a sixth of? Now, if we take 6, it's easy to find a sixth. That's 1/6. That's 1. But it's not easy to find a fourth. How about 10? 10 is not easy to find a fourth or a sixth of. How about 12? 12, we can find a sixth, right? That's 2. And 12, we can find a fourth. That's 3. Well, that's really interesting. 12, the fourth of 12 is 3, and a sixth of 12 is 2. That's really interesting. So we can split up the 12 into fourths and sixths. So wouldn't that be a really nice number to work with? So if we had 12 pieces in here, we could figure out how many pieces we would need for a fourth, and we would figure out how many pieces we need for a sixth. So let's look at 12ths. So on the top, if we want 12ths, we would need to break the quarter into 3 pieces, right? Then we would have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is a 12th. And 3 of those is a quarter. That's really interesting. 3 of the 12th is a quarter. So we can represent this quarter as 3/12. Now, how about sixth? Well, a sixth, how many 12ths would a sixth be? If we had 12 pieces all across to fill the 1, then 2 of those pieces would fill the sixth. That's really interesting as well. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now, this is a really good way to break up our 1, or the pieces, the smallest pieces to use, because 12 can be easily split into quarters or split into sixths. So now, if we're comparing 12ths, then how many 12ths is 3/4? Well, we cut the pieces, we made the pieces 3 times smaller, so they're now 12ths. Now, when there were 3/4, 3 of the large pieces, wouldn't there now be 9 of the small pieces? Now, for 5/6, we cut the sixth into 2 12ths, right? So there are twice as many little pieces, so there need to be twice as many pieces here as well on the top, because every sixth is now cut into 12ths. All right, so now it's easy to compare 9/12 versus 10/12. We know that 10/12 is actually bigger. So think about how we used common denominator. We didn't actually even say common denominator. We simply looked for that number right here that can be broken up into 12ths and sixths, and we did that. We defined 1 over that number as our fraction, as our unit fraction that we would be working with and using to compare, and then we found equivalent fractions. Now, 12 wasn't the only number. It just started with a small number. There may be other numbers that can be split into quarters or sixths. So, for example, maybe 24, right? 24 could be split into quarters or sixths. And I'll leave that up to you to figure out. Now, for number 2, and again, for number 1, remember that you can ask me questions anytime by calling in during the Q&A on Zoom. Now, for number 2, we need to be able to plot 1 and 2/3 and 5/2 on the number line in such a way that we're using the tick marks. So in other words, first we need to define what is that wonderful little fraction, unit fraction, that we can use to plot both 1 and thirds and halves. So what is that number? What is that number that we can split into halves and thirds? Now, if you know that 6, just by looking through some of the numbers, half of 6 is 3, and a third of 6 is 2. So a sixth would be a really nice basic unit fraction to be using here. So let's say that that's a sixth. Now, what number comes to the leftmost of these 3? What's the leftmost number of these 3? Is 1 or 2/3 or 5/2 the smallest number? If you think about it, well, if you need 3 pieces to fill the hole, 2/3 isn't quite enough. So I would say the 2/3 is the leftmost number. Now, where is 1? Well, 1 is going to be at 3/3. So we need one more third. How many sixths is a third? One more third. If we cut the thirds into 2 pieces each to make sixths, right? Because you need twice as many of them to make the whole, then won't you need twice as many of those pieces? So we would need 2 sixths to get to 1. It's a whole number, so we're going to make the tick mark longer. And then we would need to get to 5 halves. Well, what's 5 halves? If you need 2 of them to fill the hole and you have 5 of them, makes sense that you get 2 holes and another half. All right, so let's see if we can get to 2 1/2. Let's get to 2 first. If this space is a sixth, how many of them do we need to get to 2? We need 6 sixths. So 1, 2, 3, 4, 5, 6. So this would be our 2. Notice that I'm not counting tick marks. I am counting distances, because when we're talking about fractions on number line, or any numbers on number line, they're distances, they're not tick marks. Distances from 0 or distances between 2 numbers. So, and then we need to, so that's our 2, and then we need to get another half to get to 5 halves. So how many, if it took 6 to fill the hole, how many do we need to fill a half? 3. 1, 2, 3. Oops, shouldn't be extending that. So that's 2 1/2 or 5 halves right there. Does that, right? That hopefully that makes sense. If it doesn't, make sure that you ask me during the Q&A. Now, let's take a look at number 3. We need to plot 9, 55 sixths, and 33 fourths. So take a pause here and try to figure out what the number is going to be that's going to be on the furthest left, and also what numbers we should be using in order to, what unit fractions we should be using in order to be able to model sixths and fourths. So pause now and work it out. All right, so welcome back. Let's see. We have 9 and 55 sixths and 33 quarters. Now, how many sixths do you need to fill a hole? That's 6 sixths. And if we have 55 of them, do we have more than 9 holes or less than 9 holes? Well, 54 sixths is 9 holes. So it'd be 9 is the first one, and then 9 1/6 would be our second number. And for quarters, how many holes would you fill with 33 of them? Well, 32 will give you 8 holes, so it would be 8 1/4. So that's the order in which we're going to plot them. So this can be our 8 1/4, and this, and then we need to find 9. So our issue now, our challenge now, is to figure out what unit fractions to use so that we can get to quarters and we can get to sixths. So if we get to quarters, and sixths, at 12, just like we discussed before, would be a really nice number, because quarter of 12 is 3 and a sixth of 12 is 2. So if we use this as 1/12, then we should be able to get to 9. Now, how far do we need to go to get to 9 from 8 1/4? Well, we need 3 more quarters. If we need 3 more quarters, how many 12ths? We need to get 3 quarters. And how many 12ths is that? Well, every quarter is 3 12ths. So there is 1, 2, 3. So that's 8 1/2. 1, 2, 3. That's 8 3/4. 1, 2, 3. There's our 9. Okay. And then we need a sixth. So 9 1/6. And we know a sixth is 2 12ths. So notice that I'm not procedurally changing all of these to common denominators and then trying to figure out to count out the numbers on the number line using the common denominators. I'm still focusing on understanding and getting a sense of these numbers, right? And then using what I know about fractions and unit fractions to place those numbers on the number line. That's what builds understanding, conceptual understanding for students, not the procedures. And I'm going to leave number 4 for you to work on. And if you have any questions on that, you can come and we can talk during the